Okay, this question is on the topic kinematics. Okay, so read through the question first. Okay, and check out the formula. So first of all, right, there's a motorcyclist, and the motorcyclist is going to pass through 2 points. Okay, so if you take a look at the information, so the motorcyclist starts from point A, and then when it will hit point B in 10 seconds. So the interval between A and B is 10 seconds. And the speed at B is actually twice the speed at A. So first of all, when the motorcyclist starts at A, T is equal to 0. And because it takes 10 seconds, that means at B, it will be T equal to 10. So for the first part, if I would like to find the speed of the motorcyclist at B, I should find the original speed first. I should find the speed at A. So finding the speed at A is quite easy. You just put in a T equal to 0. And then you just punch calculator. You will get a 15 meter per second, which is the speed at A. Then you can find the speed at B, which is just doubled, because it's given to you that it's twice. So it's actually a very easy part. That's why it's only 1 mark. Okay, the next part, I will need to find the distance between A and B. If I would like to find the distance between A and B, I need the displacement formula. So I'm going to open up the bracket first. I need the displacement formula. So yes, I'm going to need the displacement formula. But then, okay, so obviously I will need to integrate this expression to get the displacement formula. But the problem will be, I already gotten a constant here. I got the constant. If I'm going to integrate now, I will get another constant. So to make things easier, I'm going to see whether I can find this constant or not. And apparently, is there a reason why they ask you to do part 1? So this speed happened at t equal to 10. Because at point B, 10 seconds already passed. So I'm trying to use this to find the value of k first. So I will try to use part 1 to help me to find k first. So you need to do the substitution. You need to do your exponential equation to find k. Okay, so shuffle the number over. When you shuffle the number over, you will get 30 minus 7.5. Okay, so this is the exponential part. So from here, you can do a ln both sides. Okay, bring down the power. You can keep your k in this format, or you can use a chain of decimal. Okay, so let me get the calculator. So you can leave it in this format for accuracy, or if you prefer, you can just punch out on your calculator. So if you punch out on your calculator, you'll be 0.0405. If you can, try to use a bit more decimal place. Okay, so that is the k that you have gotten. So now I'm going to try to get the displacement. So I need to integrate my velocity formula. So for me, I'm a bit lazy to write the chain of k. So what I did was, I'm going to integrate first. I'm going to integrate and I'm going to keep the constant first. So the K here, you can put it as this. Okay, then don't forget your job is to find the constant. So in this question, the particle start from the original point, which means, right, t is equal to 0, s is equal to 0. So do not assume that the constant will be automatically 0. So show the calculation. Okay, show the calculation, you'll find that you may not be getting a 0. So show your calculation. In fact, you will get a chain of decimal. So you will get a chain of decimal. Let me press again. So you check it out, that you will get this chain of decimal. So in my working, I use the exact format. I didn't press out too much on the calculator. So it's actually a very ugly expression. It's a bit messy here. They put in the constant. So that will be your, what's that called? Displacement formula. Okay, then the next thing is, they say the distance between A and B, and it is along a straight road, meaning there's no turning. So what you can do is, you just simply plug in t equal to 10. So you got to put in the t equal to 10, and then you punch calculator to see what you get. Okay, so punching calculator very carefully. So if nothing goes wrong, you will be getting something like this. Okay, so you can try it out. So there's a lot of, even though it looks quite simple. So there's a lot of accuracy involved. So that is the part on the distance. The subsequent part is actually quite easy. You actually need to find the acceleration. So finding the acceleration will be quite easy. You just need to differentiate. So I use my previous, okay, I use the velocity and I'm going to differentiate. So differentiating it will be quite easy. So I'll differentiate with the k first. Then later on, I will insert in the k. So I will insert in the k. And then the question asks for the acceleration when t is equal to 2. Then I'll plug it in and then I'll punch calculator. So it shouldn't be a very big issue. Okay, so keep the accuracy as much as you can. Okay, so this is the kinematic question.